Okay, so the last type of question we're going to have for the gas and gas stoichiometry question is going to be another unbalanced equation reaction. We're given a mass of a sample of copper or aluminum that's allowed to react with excess hydrochloric acid. Only the aluminum reacts. The H2 produced is collected by displacement of water. If 390 milliliters of H2 is collected at a barometric pressure of 691 millimeters of mercury at 25 degrees Celsius, what is the mass percent of aluminum in the vapor? Okay, this is a mass percent question. Remember, mass percent aluminum equals pure aluminum divided by the mass of the impure aluminum times 100%. Okay, so we need to find the mass of the aluminum from their equation above. Alright, real quickly before we go any further, let's balance this equation. There's 2, 6, 2, 3. Okay, so we're going to take the pressure, volume, and temperature information for the hydrogen and find the moles of aluminum. And then finally, using molar mass, the mass of aluminum. So we need to go from pressure, volume, temperature of H2 to moles of H2 to moles of aluminum to mass of aluminum, and then finally to percent mass aluminum. Well, what's the catch? Well, the catch is this volume here, 691 millimeters of mercury, that pressure is barometric pressure. It doesn't include the extra water. The P total is equal to 691 millimeters of mercury, which is equal to the pressure of H2 plus the pressure of the water. So in order to find the pressure of H2 that we need up here, we have to rearrange this. Pressure of H2 is going to be 691 millimeters of mercury minus the 23.8 millimeters of mercury from the water. That turns out to be 667.2 millimeters of mercury. Okay. Step 1. Done. Step 2. We need the number of moles of H2. N equals PV over RT. We need to do some conversions. Now I'm going to combine everything here. So don't get too upset if this doesn't quite make sense. You can break these apart individually. I'm just showing you all the calculations because I'm just going to put it in my calculator and run it there. We'll take the 667.2 millimeters of mercury that we just found for the pressure of H2, divide that by 760 millimeters of mercury per atmosphere. Right? Then the volume, right? Well, 0.390 liters. Because we take the volume in milliliters and divide it by 1,000. Divide by the R value, 0.8206 liter atmospheres per mole Kelvin. And then we're going to multiply by the temperature in Kelvin. Well, temperature is 25 degrees Celsius plus 273 would be 298 Kelvin. Plug this into your calculator. You get 0.0140 moles of H2. Now we got to go and do the conversion of moles of H2 to moles of aluminum. So 0.0140 moles H2 for every 3 moles of H2 you used up 2 moles of aluminum. Alright, we could stop there, but let's just go a little bit further and add the 27.0 grams of aluminum into this step. And this will give us the mass of aluminum, and that turns out to be 0.252 grams aluminum that was used up to make the 0.0140 moles of hydrogen. Are we done yet? No, because we're only here at this step, the mass of aluminum. Got to get to that percent mass. So, running out of space, percent mass equals the 0.252 grams of aluminum divided by the 2.028 grams of impure sample times 100%. Remember, that came from our information up above. Plug this into your handy dandy calculator, you get 12.4%. So this is the number that we have to put in for our answer based on all of this information up here. The gist of it comes down to be 12.4%. Alright, let me know if you have any problems.